1, 2, 3. It worked. Perfect. So thank you for joining this session. Today, we're going to talk about confusing things. And more specifically, the topic for today is going to be focused on developers. So who is a developer here? Don't be shy. What? That's it? What you other guys are doing? Platform engineering? Account manager? Security engineer? Security, SecOps teams. How many of you? Okay, so the goal of this talk is to try to make everyone happy. So how do we keep developers being productive, but without making the SecOps teams sad because they don't follow security rules? And more specifically today, we're going to talk about this aspect where a developer has applications running or some components running in Kubernetes, and some other components may be running somewhere else, maybe in AWS, maybe Azure Cloud, maybe the developers need to access a database that is provisioned in Kubernetes. So how can we manage this? Because in theory, developers, they should know how those security domains, individual security domains work. So Kubernetes RBAC, IAM roles, GCP service accounts, all of that. But the reality is it's not necessarily the case. And as a developer, we don't want to focus on that. We want to build things, not be bothered by the security guys that we hate. So today, we're going to try to reconcile everyone. So my name is Nic. I'm the head of DevRel at Otterize. So our company is focused on making developers happy and SecOps teams happy and platform teams happy. So we do that by creating open source tools that everyone can love. In terms of myself, I've been spending 7 years on Kubernetes, working with large companies, smaller companies, startups, CNI, CSI, edge, security, all these kind of things. I love running as well, so you can find me on Strava here if you want to follow me. No relation. So yeah, so today we're going to go through, so Otterize, so we love otters. And if you think about it, Otterize is a pun with Authorize. Otterize is an Israeli company, and with the Hebrew accent, when you pronounce Authorize, it sounds like Otterize, hence the otter. So this is Otis, our first Otter developer, and as you can see, is not really happy about the security team because his code is currently blocked, because he didn't actually implement all the security best practices. As a developer, is supposed to apply things like least privilege, principles. You need this zero trust sort of approach, but to stay polite, let's say he doesn't really care about that. He just wants to write code. So today we're going to see two things. First, the manual approach. What does that mean for him? So we're going to see an application that is writing to AWS, DynamoDB, using internal Kubernetes service like Redis, also using the OpenAI API. You're going to see it's a dad joke generator with 5-6 different microservices. Totally overkill, but it should be fun. And then we're going to see how Otterize, with our open source operators, we can sort of automate all this process to make his life very simple. So a couple of numbers, why we are here today, talking about security, developer security, some numbers from Cybersecurity Ventures. So in the next 3 years, we're going to kind of triple the costs of cybercrime damage from 3 trillion to tip of 10.5 trillion, which is 10,500 billion. I have to picture this in my head. It's probably the money I will never have. Even if we add up all our bank accounts, we'll be far from that. So if you combine this with the second statement from Red Hat 2023, which states that over 50% of organizations report misconfiguration at their top security concern. And then 94% of organizations experience at least one Kubernetes security incident in the past year. I mean, that's a lot. So if you look at both those statements, it's kind of easy to make a direct correlation between misconfiguration and security breaches. And if you think about it, configuration of security starts with the code, but also with the platform, and basically start within the hands of developers, right? So this is why it's important to focus on that. But it's not only about developers, it's like a team effort. So if infra or platform, they want to focus on IAM management, limits the lateral movement, the blast radius in their Kubernetes clusters. They want to establish a zero trust perimeter where there is no free pass for anyone. The principle of zero trust, hopefully everyone is familiar with this concept, is like treating every communication, every interaction as it was happening on the public internet. So nothing is trusted by default. There's no free pass. Then we have the engineering team, developers. They care about the source code. They need to focus on supply chain security, generate SBOM, secure their pipelines, and also making sure that they are using short-lived credentials, don't store any credentials on Git. Who has been guilty of that, storing credentials on Git? Some of you. Don't be shy, that's fine. Yeah. So yes, there's also this notion, how do you manage properly credentials as a dev, but you don't want the security team involved for that because it's part of your daily job, right? So talking about the security team, all focused on compliance and adaptability, and sometimes developers go a bit faster than security, actually a lot faster than security. And there's always a lag between what you're deploying, maybe not in production, hopefully, but let's say in staging or in dev, and the current compliance status, right? So you may deploy something in production, and security would raise concern because, oh, we didn't cover that bit, so we have to establish the process. What are, the typical configuration you want to implement with this? What do we recommend? So this whole cycle is kind of, slowing down the developer, development cycle, sprints, all of that. They also want to establish the root of trust, as well as minimize the response time to know what people they need to page in terms of if something is going wrong. So their responsibility is huge, but at the same time, it's a three parties effort. We cannot do put all the cognitive load on the developers, and at the same time, we can't put everything on the platform team because only the developer typically know the traffic patterns, what component talk to what component in their application. So we need a lot of communication, but what we want to try today is automate all of that so that we don't lose time for time to production. And last part is the CISO, right? So all this fear of, innovation is going too fast. That's the CISO who is probably embodying the most, scaring of the rapid pace of development and deployment, especially if you think about GitOps and all that automated deployment, CI/CDs, too fast for security teams because no one is really, in their team know what the heck is happening in my cluster. It's like 10 deployment per day. So who is doing multiple deployment in production per week here? Yeah, so you know exactly what I mean, right? So also the security teams, they may have some trouble, and just understanding Kubernetes, because after 6 years, I can surely tell you that we are seeing a proliferation, a sprawl of different operators that are automating a lot of things that don't necessarily reside in Kubernetes. So how do we manage these disjoint security domains? Who is responsible for that? How do we apply a standardized way of approaching this? And yeah, as I was saying, also the shortage of security talents. So the CISO is really, she's scary, actually. Okay, so how do we find the good compromise between keeping the SecOps team happy while at the same time keeping the fast pace of innovation? So we could take some cue from Kubernetes, because we all know, from Kelsey Hightower's quote, Kubernetes is a platform to build other platforms on tops, and it does it pretty well. So, and this idea of having a declarative management with a high-level abstraction of different components, asynchronous system that will just reconcile the desired state with what is actually running in the cluster. Well, if you apply all of that, you can sort of also apply this to security. So the idea is to have a higher level abstraction that is meant for developer to use. Right? So we're going to see that we call that IBAC, intent-based access control. So it's a custom resource And the idea is for the developer to express his high-level intent and let the low-level security configuration managed by another system that is running in Kubernetes and doing all the automation for you. So that we expose only the higher abstraction part to the developer, and then the rest of the security automation typically is compliant with what the SecOps teams want. So for that, let's go through Otis' mission. So his mission is to onboard a serverless DynamoDB database into a Kubernetes application running on EKS and create a chat completion feature using OpenAI API. So we have a couple of moving parts here. We have some services running in Kubernetes. We have a serverless database in AWS, and we want to access OpenAI API on the public internet. So how do we manage all those security domains? So we need to configure Kubernetes RBAC, service accounts. So this is kind of out of the domain of our operator, but basically what you want to do is you don't want to overload the service account permissions. So it's like having a specific service account per application, per pod, per deployment. This is the right approach. Then you need to configure IAM roles in AWS, network policies within Kubernetes, and egress control to talk to these public internet elements. So how many of you are familiar with AWS IRSA? IAM role for service account, a couple of you. So in the next section, we're gonna take a look at what manually that involves. So how much time do I have now? It's like 20 minutes, right? I think that's it. Anyway, so first part, we take a look at AWS. Second part, networking. So if you were to do that manually, IRSA, the principle is to map out a Kubernetes service account with roles and permission in AWS. So for this, you need multiple things. We start with number one. You need to create an AWS roles with permission. In our case, it's DynamoDB resource. So you want to allow so here DynamoDB column star, it's all the DynamoDB permissions in AWS. You want to apply it to a particular ARN. I just put a wildcard because the full ARN was too large. But typically you will find here the ARN to the table you want to write to or to read. This is part one, permissions policy within the role. Then the role has another dimension, which is the trust relationship. And this is what is used by RSA. So the principle is that you establish a trust between your cluster, represented as the OIDC provider, right? Because you need to generate a JWT, JWT. So you need this OIDC provider. And then the second part, you represent the service account that is running in Kubernetes, right? So we have a trust relationship between the cluster, EKS, and the service account. Right? So this is the first part. We need trust relationship, permissions policy. Then in Kubernetes, you need your pod or your deployment, and you need the service account. Service account, you need to annotate that with the role that you have created there. And your pod, classic, you just have to attach the service account to your deployment or to your pod. Right? So you have to do this manually. As a developer, I hate to deal with IAM roles. It always takes me hours, and going through the documentation, they making sure it's correct, not working first time, blah 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 blah. Anyway, so that's the first part, and this is the application design for today. We're going to see I'm going to do a live demo. Hopefully, it's going to work. So the idea is that one. This is the dad jokes overkill application. As a user, I want to request a joke from the joke server running on an HTTP web server written in Go. This guy is publishing a message on NATS. I want a joke. The joke worker is subscribing to that queue, saying, OK, I'm going to pick up your request, and then request the joke on OpenAI API, store it in DynamoDB, and in Redis. Right? So that's and then from there, the joke worker will send it back to the joke server, and the joke server will serve the joke to the user. Totally overkill, but it illustrates the purpose. And then within Kubernetes now, I have to deal also with security best practices, right? So I need to have network policies applied everywhere, typically to apply the least privilege principle and reduce potential lateral movement if one of those services gets compromised. So we want to enable all users to access the joke server. So here I've just represented the relevant part of the network policy that you would have to configure, right? So everyone access joke server. The NAT service is ingress allowing joke worker and joke server, so matching those labels. Redis, we also need access from the joke worker. So we have from pod selector match app joke worker. And on the egress, if you want to apply egress policies, unfortunately in Kubernetes, you can't just specify a domain name. That's the problem. You would have to go for Cilium or Tigera or like custom network policy that supports DNS expression, if you like. So here, typically, this is what you have to do. Translate this into IP addresses, potentially hitting load balancer and update it as you go, and doing this manually. Yeah, it's really horrible, right? So that's the challenges for Otis. He's not an expert in AWS, so it's going to be time-consuming. Really error-prone at scale. It's just for one application. If he's got like 5, 6 applications and manage all that, it's going to be a nightmare. AWS is not the same as Azure or GCP. Totally different security domains, language. And also, as its application is evolving, how do you make sure that it's still aligned with the best practices, right? Because as new PR are created, new feature built, you may need to introduce new services. You need to keep everything up to date, right? Kind of difficult. And of course, you can't offload everything to the platform team because only devs will know the patterns within their application, right? They don't update necessarily the documentation. We are not good at writing documentation in general. And also, cognitive load fully on the developer doesn't work either because it takes, ages to learn about all the different security languages. So this is why we have introduced IBAC, intent-based access control, which is this higher level language that allows the developer, here's a quick example, to express what he wants to access. Like here, for example, you have, I want to access from my checkout service, I just want to access my email service, and that's it. Right? This is what I want as a developer, and the rest, I don't really care. If I've got an AWS resource, same thing. And let the low-level policy be managed by something else, by a system, not by the platform team, because they don't want to do it manually, just by some automation. And again, we are in Kubernetes, so we can create operators that can do that for us. So if we look at our application, we can achieve the same thing as complicated as before just with a couple of lines, really. So here we want to access NATs. So from the joke worker perspective, service joke worker, I want to call NATs. Okay, I just mentioned it. I want to call Redis. Okay, I want to call different domains. OpenAI API, DynamoDB, and also STS to get this short-lived token from IRSA, right? And then, last one, I want to access my DynamoDB table. This is this particular resource with any permission under DynamoDB. I can add more granular permission if you want. Or I can just specify all permissions because I'm an admin of that particular jokes table in AWS. Right, so that's basically it. By doing this, we want to achieve exactly the same thing as before, configuring RSA, networking policy as well. And how does that work? Well, this high-level abstraction language is high-level enough to enable policy as code for a lot of different security domains. So we've seen network policy, we've seen AWS. If you want to implement layer 7, there is Istio as well. We can do that with databases. And since it's a community-based project, open source, we are also looking for the community, like you guys, to submit other use cases. And if you want to as well, get involved and write those lower level abstraction to do the automation for developers, right? And also we have some extra capabilities, such as we can detect the traffic that is happening in the cluster using classic eBPF, not eBPF there. So detecting all the TCP sessions between different components and build client intent for you with the syntax I've mentioned before. So you don't have to know exactly how your application talks. As long as you're running the application, we can tell you, okay, this is what you need in the client intent, and then you can just apply this to your kubectl apply -f and job done. So, and if we see new traffic coming, we can raise pull requests with the content of the new client intent that can be validated by the security team or not. This is how we make different teams work together, right? So 10 minutes, is this correct? So I'll go through the demo. Okay, so that was a lot, but now let's figure out what we want to do. So here, I'm in my Kubernetes cluster. I'm going to deploy my application. And as part of my application, if I go to where is it here, custom resource, we're going to start first by allowing, we're going to go step by step. First step, we want to talk to AWS. So I need this client intent, allowing the joke worker, remember, talking to AWS DynamoDB. So for this, if I go into joke worker client intent, simple, right? Couple line of code. I just have to know the name of my DynamoDB table. This is all I need, like the full ARN. You can also specify a wildcard, and it will give you access to all the table in DynamoDB, which is not necessarily something you want. But as easy as that, the whole automation around IRSA will be done for you. And it's part of my application deployment. I don't know if any of you knows DevSpace. Yeah, one, really? So yeah, DevSpace is an application, let's say, lifecycle tool that where you can create a lot of pipelines, like deployment pipelines, you build pipelines, all those sort of things, and you can deploy Helm chart and all that stuff, cool stuff. So I'm going to deploy this application with DevSpace. So DevSpace deploy is going to deploy my application with that particular client intent so that I can access AWS DynamoDB. So I know I have an issue with one of the Helm charts, so let's deploy this. And I'm going to have to change the version of my Redis operator normally. So let's go to the NSCA dev. I'm going to go to the Redis deployment, Redis operator. I'm going to find the image. So for one reason, this image doesn't exist on Quay since yesterday, because I was doing a demo today, you know. Obviously, right? I think this one is working. Okay. Let's go back to pod. Error. So it's error because it's so the server is waiting for NATs and the worker is waiting for Redis. So normally we should have like a couple of crash lookback. So it's running now. Come on. Okay, in the meantime, we just see this one is running, the client intent. So client intent deployed, and this is the one from AWS, right? So I should be able to already see a IAM role that has been created, and some of the permission attach, please work, please work. Please work. Refresh, refresh. So you can see that the permissions has been added, as expected, and the trust relationship has been configured between my OIDC provider for the cluster and my service account, which I'm using default, but you should not do that. Right? So this part is working, so I should be able to write into AWS. So everything is running, so I want to make sure my server is exposed locally. And I want to generate some jokes and then check the AWS table, DynamoDB table, if I'm allowed to write. Okay, let's generate 10 really fun jokes. Work, work, please work, please work, please. Oh. Here you go. I only know 25 letters of the alphabet. I don't know why. Yeah, could be better. Okay, so anyway, so let's check the Dynamo. Someone is laughing. It's not, it's not funny. Okay. Tables, I've got jokes table, explore table item. Yeah, it's there, right? So I have permissions to do that. So as a developer, I didn't have to configure anything. I'm just happy. Now, I don't have any network policy, right? So I want to apply the rest of the service configuration. I need to talk to Redis, NATS, etc., etc. You're laughing. So let's apply the rest of the policy. So we go to the policy directory. The client intent. So here I just have like the one I've mentioned before, the joke worker, accessing NAT, Redis, I'm adding the internet domain, all sort of nice stuff, right? So this is what the network mapper, which is our operator that detects the traffic, has recommended for me. So typically, I can do it manually, or I can just let it do it for me. So Kubernetes applied as F, client intent. OK, so now I can see network policies have been generated for me. Right, this is what I wanted. So my client intent are configured there. So I can see now I have a bit more. The joke worker has been modified to also include, on top of AWS, NATS, Redis, and the different internet domain. I've got the joke server needs to access NATS, that's it, etc., etc. So just high level. And the network policies, as I said, have been generated. We can take a look. So you can see that we are automating this by applying labels where we need to, and just setting this network policy with those labels. So we're kind of labeling what you want to access, who is doing what, and base all the network policies on those labels. Typical thing how you do it in Kubernetes. But as a dev, you don't have to worry about this at all. Right, so, and just check that it's still working. Another 10 jokes. OK, let's stop it. All right, 5 minutes. So, and the last part I want to show you is, so we have the ingress rule. I just want to enable egress as well. So for this, I'm just going to update the Helm chart with that particular option. And we're going to see in the network policy, something interesting is going to happen. I'm going to have more network policy generated, normally, if it works. Let's wait. Maybe Netanel didn't do his job correctly. If it doesn't work, it's your fault. It's not happening, isn't it? Please work. No, it doesn't want to. Oh, here you go. So now if I just check, oh, and then it disappears. Oh, and then it's back. OK. So please stay here now. OK. The last thing I want to show you is how we update the network IP address. So you can see here, you can see all the blocks. Is we are populating the status of the client intent with all those IP addresses. So if you go to the client intent, the joke worker one. Right. At the end of the file, you can see status here. Our operator is constantly resolving the DNS name and setting the IP address for that. Right. So now, as a dev, I'm fully covered. Right. 2 minutes. So that was it for the demo. It worked. So hopefully it was convincing. Yeah. Oh, OK, so let's go back to the presentation just to finish it. So benefits, time to production. We're saving a lot of time for devs. Security posture, we kind of now are always in line with the best practices as the code evolves. As I mentioned, if the code changes, we can also raise PR to create those new client intents. Because we have compatibility, we support network policy, Istio authorization policy for layer 7. We reduce the attack surface, and everything is locked down. We also reduce lateral movement with all those network policies and authorization policies. Developer focus, because now, of course, developer is not frustrated anymore. He doesn't have any, or she doesn't have, they don't have any roadblocks. So everything works perfectly. Key takeaways for today. Security is a team sport, right? It's not individual sport, so play nicely with all the teams. I think I show you how we can make everyone happy. Declarative access control, I think this is the future. This is how developers should do that. This is how the platform team should also implement it. And what we often see is companies that are big enough try to reinvent the wheel and do that in-house. But it doesn't guarantee that it's going to be well done. It doesn't guarantee that it's going to be aligned with the latest best practices. So long story short, get involved in that open source project, right? And yeah, empowering developer is very important. Call to action, and I'm going to finish with this. If you are interested, you can just scan this. We have a couple of tutorials that you can go through with all the integration you want. Join the Slack community if you want to chat with me. I'm a cool guy, easygoing, so let's talk about everything. If you want to talk about running, get into running, you're looking for a coach, I can help you as well for free. And then explore further. I wrote an extensive blog post on how, if you're using AWS and ACK, which is AWS Controller Kubernetes, that allows you to create AWS resources using an AWS controller, right? So we can automate this as well. Very technical, deep level blog. And please rate this talk, just scan this. I think you can from 1 to 5. And again, if you have also the QR code for any questions you have later on, or I'll be at the booth. And that's it for me right on time. Thank you, guys.